In this video, I want to talk about how we can solve linear equations. So for this first example, we want to solve for x. We have 3x plus 7 equals 19. Okay, so the first step is the end goal, I should say, is that we want to totally isolate this x here. And the way to do that is to get rid of anything that doesn't have an x on that side of the equation. So since I have a 7 here, I need to get that 7 on the other side of the equation. And I have plus 7 here, so I want to subtract 7 on both sides, and that will get rid of the 7 here. So this will become 3x equals 19 minus 7, which is 12. Okay, now I have 3x. I need to isolate this x, and since these are being multiplied, if I divide both sides by 3, that would do it. Because 3 divided by 3 is just 1. It reduces to 1. And so I will have x is equal to 12 divided by 3, which is 4. So I claim that x equals 4. And that is saying that 3 times 4 plus 7 is equal to 19. And we can see that, yeah, that's true. Okay, great. So let's look at another example and see if we can't learn anything more about this. Okay, so for this one, we are solving for c here. We want to solve for c. And we have 4 minus 4 times the group 3 plus 5c equals negative 21c minus the group 8 minus c. So there's a lot to be done for this one. Now, we talked about that we want to simplify parentheses first in our order of operations. So I'm going to distribute this 4 like this. And so I will have, for this line, I'll have 4 minus, and then 4 times 3, which is 12. Negative 4 times positive 5c would be negative 20c. Okay. And then for the right-hand side, we still have 21c, and we have this negative sign, and it's like a negative 1, so I'm going to distribute that negative 1 to both sides, or to both of these. So I have negative 8 plus c there. All right, let's keep simplifying, seeing what we can do. So I have 4 minus 12. Well, that's going to be negative 8 minus 20c. And on this side, it looks like I have negative 21c plus c. Well, that's going to be negative 20c. And then I have that negative 8 here. Okay, well, I've noticed something strange has happened. And the equation is now equal to itself. It's the same thing on both sides. But we can keep going and see what happens, but I'm kind of noticing that right now. So I want to isolate the c, so I'm going to add 8 to both sides. When I do that, the 8 goes away here, and it ended up going away here. So now I have negative 20c equals negative 20c. Well, that's strange, but let's see what happens. If I divide both sides by negative 20, I'm going to get c equals c. Okay, well, that's very strange, right? So what happened? What is going on? And when this happens, what it means is that it could have been any real number would have worked. So if you ever find this, like c equals c, sometimes we get 0 equals 0, things like this, this means that all real numbers would have worked. And we actually could have noticed that right here on this step. Whenever the equation is equivalent to itself, the answer is all real numbers. Okay? So there are infinite solutions to c. It doesn't mean that c is equal to infinity. It just means that that there's infinite solutions, okay? So all real numbers, there's infinite solutions. All right, so that was kind of a strange problem. Let's move on to the next one and see if anything weird happens again. solve for the equation for y. I have 1/3 y plus 8 equals 1/6 y. Okay, well, I need to get all of the y's to one side, and I need to get all of the numerals on the other side. So I think how I'm going to do it is I'm going to move the 8 to the other side. So I'll subtract. I have 1/3 y equals 1/6 y minus 8. And then I can subtract 1/6 y here on both sides. And so what do I get? I get 1/3 y minus 1/6 y equals -8. Okay, so we need to combine these fractions. So we're kind of reviewing lowest common denominator here. Well, I have 3 and 6. I can easily make a 3 into a 6 by multiplying it by 2. So I can take that away and just take that away. So that would become 2/6, and that really simplifies it. Now I just have 2 minus 1, and that's 1/6 y equals -8. Okay, so I need to get rid of this 1/6, so I can divide both sides by 1/6. I find it easier to multiply by the reciprocal, like this. This works well. Everything reduces to 1. And so now I have that y equals -8 times 6. And I believe that's 48, right? So we found that this is -48. All right. So hopefully that helps you with that type of problem. Now for the next one, we have solve the equation for x. We have 0.3 times x minus 9 equals 0.8 times the group x minus 3. Now the technique I like to use when I have decimals like this, I like to take them away from the decimals and turn them into fractions. And I'm going to show you in just a second of why I would do something like that. So right now I'm just going to show you what I said. So 0.3 or 3/10 would be 3 over 10, and 0.8 is 8/10. So I can go 8 over 10. And the reason I want to do this is when you have something like this, and this is going to come up later in the lesson as well, if you have everything over the same denominator, then you can actually multiply the whole equation by that denominator. So since I have 3's over 10 and 8's over 10, I'm allowed to multiply both sides by 10, right? I can go 10 times 3/10 x minus 9 equals 10 times 8/10 x minus 3. If I can add both sides, I can multiply both sides. It's just that easy. So this reduces to 1, and when I do that, I don't have fractions anymore to deal with. So now I have 3x minus 9 equals 8x minus 3. And this idea of getting everything over the same denominator and then multiplying by that denominator is a really, really helpful skill to have. Okay, that's a really helpful skill to have, especially in the coming parts of the lecture. So 3 times x, 3x minus 27 equals 8x minus 24. All right, so I need to put the x's together and I need to put the numbers together. And I think the way I'm going to do that, I like to solve for the positive x. So I'm going to subtract 3x on both sides, and I'm going to add 24 to both sides. And that way, I'm able to solve for a positive x. All right, so on this side, I have 24 minus 27, and that's going to be -3. And on this side, I have 8x minus 3x, and so that's 5x. All right, now I want to divide both sides by a 5, so I get x equals -3/5. All right, so that's what I think x would have to equal for these to be equivalent. And the thing I really want you to take from is having that these could be over the same denominator.